I am in charge of Line Android app, and this is my presentation. I'd like to talk about modernizing the development of Line Messenger for Android. My name is Oshi. Nice to meet you. The Line app was released in June 2011, and it has been 8 years, and it is almost 9 years this year. In 2011, there was the large East Japan earthquake. And do you remember what was the situation of the smartphone app at that time? And as the slide shows, in 2011, with Android, it was version 2.3. Gingerbread was mounted on the latest devices. With iPhone, the iPhone 4, it was still iPhone 4. So only SoftBank was selling iPhones in those days. And I'd like to ask you, anyone who is developing Android, please raise your hand. Quite a few. And since 2011, have you been developing Android app? Well, not many, but still some people. From those days, since the Line Android app was released, anyone who has been developing continuously, I have. And the people who raised hand probably remember 8 years. It's such a long time. And it is almost the majority of Android history. And the Android development environment has changed dramatically. But in order to continuously evolve app, we need to follow the changes always. Therefore, we are the client Android app team, and we have continuously followed the changes. That is our important mission. And therefore, as the slide showed, there are so many things that we have been doing. And I won't be able to cover everything today, and therefore I'd like to focus on 2 topics. First, Kotlin and Kotlin coroutines. And the other is project Multimotorization. To begin with, I'd like to talk about Kotlin. Once again, I'd like to ask you, not just Android, but anyone who is using Kotlin, please raise your hand. Wow, a lot. Then anyone who is using Kotlin coroutine, half of you are using coroutine. Then I'd like to talk about Kotlin. First, the Line Android team, Line Android started implementing Kotlin or started considering Kotlin in early days of 2017. From April 2017, we used Kotlin for unit tests. And we began as a pilot. In parallel, we created coding conventions. Basically, the Kotlin official coding conventions, and we added some rules to the conventions. It was such a large project, so we had some detailed rules and created coding conventions. And we thought it was quite successful. And then from June 2017, we started using Kotlin in production at scale. And new code should be written in Kotlin. And if we added features to existing code, we decided to convert Java code to Kotlin first. And that was a rule to develop. At this moment, the Line Android project, and these are production code without test codes, And half of it is already changed to Kotlin, because in terms of number of rows, it's more than 1/3. And that is already turned to Kotlin. Again, well, as you may know, what are the benefits of Kotlin? 100% interoperable with Java. That's what Kotlin says. Also, Android Studio has a converter function from Java to Kotlin. It is suitable for phased implementation for large-scale existing projects. These two are necessary. These are assumptions, and with Kotlin, the null safety or immutable collections to benefit from multiple functions. Among all, recently, the coroutines are drawing people's attention these days. What is Kotlin coroutines? To make the asynchronous task simply described and famous, or the previous de facto Alex Java needs to connect function calls. But in case of code routines, it is procedure writings. It's simpler. It can be written much simpler. That is the biggest characteristics of Kotlin. The C# and other languages, or async and await language functions, are similar to Kotlin. The Kotlin coroutine is such a convenient function, so we wanted to implement sooner, but it takes a long time to develop. Finally, Stable 1.0 was released about a year ago, October in 2018. And when we introduced Kotlin in April 2017, it's been a long time since the first release of Kotlin. We have had a hard time using Kotlin for a project. And before coroutine implementation, what sort of libraries did we use for asynchronous coding at Line Android app team? We have a history of more than 8 years. Basically, we did a refactoring and we renewed by refactoring by old codes the async task or old Android executor class used as raw codes, or Alex Java, Java 1, and Java 2 used at the same time, and they remained. So it was not structured. It was not organized. Therefore, with the Kotlin coroutine implementation, we decided to unify the asynchronous libraries. But as mentioned earlier, it took time for the stabilization of Kotlin coroutines. Continuously, old codes need to be migrated to Kotlin coroutine in a phased approach. So we had one step before, and the existing codes turned to Alex Java 2, and we unified Alex Java 2 as the common code, because there's a de facto. If we write with Alex Java 2, it can be easily used for Kotlin coroutines as well. And also, as mentioned earlier, half of codes are still in Java. And to call Java from Kotlin coroutine is almost impossible, but with Alex Java 2, we can call Kotlin coroutines. And that's why the existing the Java were standardized to Alex Java 2 to relate it to Kotlin coroutines. That was a plan to migrate to coroutine. That was a policy that we decided. In the future, if we assume that we are going to migrate to Kotlin coroutine. How do we use RxJava 2? We decided one rule that was using RxJava 2 to do the asynchronous processing. Rx single object was a function, and that was a return value. So that was the rule that we set. So this format, we call it async function. So here, foo async returns single result. This is async function example. So how do we create this? So this is a more specific example. The function at the top, this is, so from a URL, specified URL, we obtain JSON data. That is the function. And this is done synchronously. So the network operation is completed, and until then, the process is not returned. If we call this as is, then it would block the UI. Therefore, we need to run this asynchronously somehow. So this blocking function would be used as async function. That is the example at the bottom. So single from callable, and then subscribe on schedule IO. So this is how we write it. By doing this, the blocking function earlier can be run on the IO thread in the background, and the result would be returned as Rx single object. That is the async function. So basically, this way, the asynchronous functions are written. That is the rule that we shared. And when we use this, what do we do? So this async function, so observe on main, and then it would be subscribed. So the result from JSON would be reflected on UI. So as you may know, this is the basic usage of Rx. So this is a more complex example. So if there is another async function, so what do we do then? The first async function result would be processed by another async function, and that result will be used. In that case, in this example, flat map is used to connect the two functions. So flat map, so the operator would be used for calling the functions, and then the process would be connected. That is the async processing using RxJava. So based on such rules, how do we convert it into coroutine? So the async functions earlier can be easily called by coroutine. So let's do that. This is the async function earlier to be called by the coroutine. And I will explain about the wait part, but this is to start coroutine. And then once the coroutine is started, async function is called. After that, .await is placed at the end. So you can call async function from the coroutine normally. And then JSync object, normal object, not single object. It can be received as normal object, and then UI can be changed. By writing this, without blocking the UI thread, we can do the async processing as if it is synchronous processing. That is the characteristic of coroutine. So another example here. So if there are multiple async functions to be called, then it's easy with coroutine. So you just put await on each. Then
Two methods are called one after the other, and then you do the update. So it's very procedural, connecting the functions. Compared to RX, connecting functions, this is much simpler. So RX Java can be replaced with coroutine. The basic policy is that the caller would be changed to coroutine. And the caller is made into coroutine, and then the one who is called, the async function, would be rewritten. How do we rewrite the async function? So function to be called by coroutine is called suspending function. It's replaced with suspending function. So there's a modifier called suspending, that is the suspending function. So this can be called without await. So async function is at the top. So suspending function similar to it is shown at the bottom. And this is the blocking function on IO thread, and then it would be returned. That is the suspending function. So from coroutine, you can call this simply, and that's it. So through RX Java, once unifying the RX Java, it can be replaced with coroutine. That's how we are introducing coroutine. However, currently, there's one important thing. That is the cancel of coroutine, cancellation of coroutine. How do we cancel the processing of coroutine? That is a very difficult issue. So RX Java, when it is used in Android app, the basic usage is that activity and fragment are in the stopped function. Then you would cancel and dispose the processing. That's commonly done. Therefore, in our old code as well, it's similar. So on stop timing, you want to cancel the processing. But in the case of coroutine, there is no library to do it. Android's Jetpack library has lifecycle scope. So when it is on stopped, it would not cancel. It would only suspend temporarily. That is the Jetpack library. But to cancel at the time of stopped, there is no library for it. RX Java code with the same policy, there is no library to do the canceling with the same policy. That is why we created a new class, that is Auto Reset Lifecycle Scope. This class is published on GitHub as open source library. And this is an example using it. So at the top, coroutine scope, there's another new scope to be defined. And that is the auto reset lifecycle scope, and the fragment is stopped, then automatically it will be cancelled. And then by calling and starting the coroutine here, automatically this coroutine would be cancelled when the fragment is stopped. So the conventional method is done so that old asynchronous processing code can be done using coroutine. And actually, from July of this year, we are migrating to coroutine. So let me summarize what I've talked about so far. So what we have been doing in introducing coroutine. First of all, RX Java 2 is unified, and then we migrate from that to coroutine. And for that, we created rules and shared amongst the team. And for some parts, such as canceling, we had to create a library, and we deployed it in our team. Sample code is published as open source code on GitHub. So please look at it on GitHub.
That is a line Android app Kotlin coroutine explanations. I'd like to move on to the next topic. Next, the project multimotorization. Why did we need to multimodalize? To separate the project into modules, the source code can be split by function. Then if we make changes, we can understand how the change affects. We can understand the scope of impact, and with the change of source code, we can understand the scope of impact of changes. Therefore, we can increase extensibility. It is hard to quantify, but easy to understand specification is to increase the level of granularity, speed. And the Line Android app, as mentioned earlier, excluding test code, the production code is more than 1.6 million lines. It takes such a long time to mute because it's so big, and we can shorten the mute time by modularizing the app. And also, the feature such as dynamic feature module, which is on-demand delivery feature, which is quite new, is utilized. So app function can be split into the user devices and can be downloaded. And the installed app size can be reduced. So modularization has a lot of benefits, but if we want to do it, in reality, there are dependency issues, and it's quite hard to modularize. Therefore, I'd like to talk about the policy or the method of modularizing. I'd like to show you the diagram to talk about the specific. This is a monolithic, simple, big project. This shows the environment of classes, the right-hand side below. Let's make it an independent module. In that case, what do we do? First of all, there is a facet class, which is an entry of the functions, and this is a facet pattern of design. That's what I mean by facet. I will give you the specific example. For instance, depending on message app, such as Line, the selfie camera feature can be considered as an independent feature, and the camera feature needs to be launched, and the method to launch the camera feature is in place in facet. The method to call a function that is defined in facet. And outside the function, if you want to call that function, you need to call the facet class. That's a rule that we decided to use. And going back to the chart that I showed you earlier, this is a foo feature, and there are 3 classes, and we call the feature from the 3 classes, and the calling from the 3 classes are sliced as a facet class. And then what we need to pay attention to is this is going outside, the call going outside the facet, we don't have to touch. So the call to the feature needs to be sliced as a facet class. That's important. And so far, so that what we need to do next is to split into implementation class and interface of the facet class. Other classes can work as long as they know the interface. In other words, the example that I showed you earlier, the full facet, it is split into interface and implementation. And then it's almost outside the feature. Knows only full facet. That's good enough. Then, at a glance, you can split them into modules. It's so easy. And from app module, the module is just looking at the facet. The full module depends on app module. The modularization is complete, I want to say, but there still is a problem to solve. I said earlier, the facet, if it knows a facet, then good enough, but the code, the actual code is, if you want to call the facet method, how do you get this instance? That is a problem. You might guess, why don't you use DI? Right, depending injection, the DI tool might work. However, I want to ask you the question once again. And if you're developing Android, Dagger 2, anyone using Dagger 2? Raise your hand. A lot of people using Dagger. Dagger is a de facto. And there are other DI tools that are popular these days, and they are multi-module. In order to solve the multi-module project problem, it may be quite cumbersome. And we decided to develop our unique library in order to solve this problem. And this is also open in the project that I showed you earlier. Using this, why do we have to create our own? Because it would be much easier to develop. How would it be? Add the companion object to facet class, and I can add some codes, some lines of codes. And on the implementation, auto service annotation is added. And that's all. Like Dagger, don't need to write component or modules at all. As simple as this. And the dependency problem is solved. If we want to use it, the full facet method called, then by component full facet, just write this line. This will solve the full facet implementation issue. Even outside the module, you can get it easily. As I mentioned, from facet, the dependency problem can be solved. And this is the completion of the module in a real sense. That's what we do project-wise. Now, I'd like to talk about left-hand side below and the right-hand side above. We can do similar things. We do similar things. We create facet class and then split them into interface and implementation. Then it will be like this. The app module only knows facets of each modules, nothing else. And the features, if they call each other, if the module knows a facet of the other module, then just call the facet. That's all. By splitting the project, the big monolithic project can be split into feature modules. This is a policy of Line Android project, and we successfully modularized. I'd like to summarize. The entry of the function is facet, extract the facet, and from other features access only to facet, and then the facet is split into interface and the implementation. Then the problem of interdependency can be resolved with a Richie. That's the name that we put. With which we can solve the interdependency problem. Now that I summarized, as I mentioned again and again, Line Android project development made some important independent libraries, and we put those libraries together and we call it Rich. And it's an open source project, and we open it to the the GitHub.
So coroutine that I talked about today, and multimotorization, and solving the interdependency, as well as view model and OK HTTP. So such small libraries are grouped together, and it's called Lich, and it is placed under this URL. It is published. So please check this library out so that you can utilize it in your development as well. And if you like it, then please give us the star on GitHub, and that would make us very happy. So that concludes my presentation. Thank you very much for your attention.